90.0 milliliters of hydrogen gas was collected over water at 25 degrees Celsius and a pressure equal to 755.0 millimeters of mercury. How many grams of CaH2 decomposed assuming the vapor pressure of water at 25 degrees Celsius is 23.8 millimeters of mercury? And to aid us in this question, we have the CaH2 plus 2 waters giving us CaOH2 plus 2H2 chemical equation, and this equation happens to be already balanced for us. So to look into this, we need to know how much CaH2 decomposed in this particular case. So we first have to use some of the concepts from our previous video to calculate the partial pressure of hydrogen in this case. And our partial pressure of H2 is going to equal the total pressure minus the partial pressure of the water. So in this case, our partial pressure of H2 is going to be the total pressure, which is 755.0 millimeters of mercury, minus the 23.8 millimeters of mercury, which is our partial pressure of water. So our partial pressure of H2 is going to be 731.2 millimeters of mercury. And now we need to figure out how many grams of this, compound decomposed. So we need to go from pressure to moles, which we can use the ideal gas equation. So if we take PV equals nRT and we rearrange that, we know that the N, or the number of moles of H2, is going to equal the partial pressure of H2 times the volume divided by R times T. So this is going to be 731.2 millimeters of mercury. Remember though, we need to convert that to atmospheres because that's what our constants units are using. So 1 atmosphere is 760 millimeters of mercury. So those guys then can cancel out. Then we look at the volume, which is 90.0 milliliters, which will be 0.900 liters, divided by our ideal gas constant, which is 0.0821 liter atmospheres per mole Kelvin, times 298 K, which is the temperature that we're at here. So if we go through and we calculate, this gives us the number of moles of H2, which will equal 0.003541 moles. Okay, so this is the number of moles of the hydrogen that were produced. So if we want to figure out how many grams of CaH2 decomposed, we need to relate the H2 here with the CaH2, and we can do that with the stoichiometry of the chemical equation. So we're starting with 0.003541 moles of H2, and we want to convert this over to grams of CaH2. From the balanced chemical equation, there are 2 moles of H2 for every 1 mole of CaH2, and for every 1 mole of CaH2 from the periodic table, we can get 42.10 grams. So this is going to give us a value of 0.07453 grams of CaH2. And this will be the amount of those grams that decomposed when we obtained this particular amount of hydrogen. So to recap here, we use our partial pressure expression to get the partial pressure of hydrogen is the total pressure minus the pressure of the water. Then we can use the PV equals nRT expression to get how many moles of H2 are present. We can then take the number of moles of H2 and convert it to grams of, in this case, CaH2. And that is what's given here as 0.07453 grams of CaH2.